Hello everyone, welcome to my YouTube channel. Today's session is especially for AS level chemistry students. Today we're going to talk about the nomenclature, and I will try to cover all the nomenclature like the nomenclature of alkane, alkene, halogenoalkane, aldehyde, ketone, carboxylic acid, ester, amine, amide, acyl chloride, etc. Now, there are certain rules which are used for the nomenclature or naming organic compound. So these are the three principles or three rules a student of AS level he should keep in his mind. Number one, select the longest carbon chain. If you have the different types of structure which may contain some branches or some substituent, so select the longest carbon chain. Then second point is that give the least number to the branch or the double bond. If you have some substituent or branches attached with the longest carbon chain, or if there is a double bond, then start numbering from either side. Branch or the double bond should be given the least number. If you have more than one functional group, like carboxylic acid, alcohol, if both are present at the same time, sometimes the double bond, alcohol, both are present at the same time in the same organic compound, then you will have to use the priority order. So this priority order will be explained later on. Let's look at the three types of organic compounds like alkane, alkene, and halogenoalkane. Alkanes, they have the general formula CnH2n plus 2. Alkenes, they have their general formula CnH2n. And halogenoalkanes, CnH2n plus 1. X stands for halogens like fluorine, chlorine, bromine, and iodine. Generally, the halogenoalkanes, they just have one halogen in replace of hydrogen. If you replace one hydrogen with one halogen, you will get a halogenoalkane. Although the halogenoalkane, they may contain more than one halogen, but in that case, you will have to change this general formula. Now, the organic compounds like alkane, alkene, halogenoalkanes, they can be represented in the form of their structural formula and skeletal formula. So this is the structural formula of an organic compound. As you can see that if you want to identify this compound from the rest of the compound, like if you have some other compounds, like if you have this type of compound or this type of compound, now you can see that the molecular formula of this organic compound is 1, 2, 3, 4, 5. There are 5 carbon atom and 12 hydrogen atom. So there are 5 carbon atom, but there are 10 hydrogen atom. Now, the molecular formula of this organic compound, there are 3 carbon atom, then 3, 5, 6, 7, 7 hydrogen atom, and 1 chlorine. So from the molecular formula, you can identify that this compound follows CnH2n plus 2. So this is alkane. This organic compound, although there is no double bond represented or shown in the formula or the structure, but it follows C5H10. So that's why it is 1, 2, 3, 4, 5. This is alkene and this is pentene. And this is halogenoalkane. But now count the carbon atom. Number one, select the longest carbon chain. Now you can see that there are 5 carbon atoms. So that's why this is pentane. Pent is the code letter or this prefix for the counting of carbon atom, and ane is the suffix or ending code. So this compound is pentane. Although this compound is pentene, but just look at the position of the double bond. If you start numbering from right hand side, 1, 2, 3, this is 3. So double bond starts from third carbon, 1, 2. And if you start numbering from the left hand side, this is first carbon, this is second carbon. So here is the double bond because we have reduced 2 hydrogen atoms. So here is a double bond. So you can see, although this is pentene, but more specifically, this is pent-2-ene. Now, this halogenoalkane, count the carbon atom. There are 3 carbon atom, but the prefix for the chlorine is chloro. So that's why, first of all, use the prefix for halogen, which is chloro, 3 carbon atom, prop, and there is a single covalent bond. So we can say this is chloropropane, but this chlorine, it may be on the second carbon as well. So more appropriate word will be the 1-chloropropane because the chlorine is present on first carbon. Now, if we look at the skeletal formulas of these organic compounds, there are 5 carbon atom. So you can draw the skeletal formula like this. This is the skeletal formula of pentane. There are also 5 carbon atom. So if you want to draw the skeletal formula of pentene, this is the pentane. And if you add one double bond here, you will get the skeletal formula of pentene. 3 carbon atom and 1 chlorine atom. So here, these are the 3 carbon atom. And if you want to add one more chlorine atom, so you'll have to add an extension here. And this is 1-chloropropane. Now, if you have the different types of alkane, alkene, and halogenoalkane, let me tell you in a different way. For example, if I have CH3 two times, CH, CH2, CH3. Now, it means that the CH3, two CH3, they are attached with this carbon. So you can say this is a structure like this, CH3, now CH2, and CH3. Now, this is the longest chain, which contains 4 carbon atom. And on the second carbon, there is a methyl. So this structure is 2-methyl butane. The longest chain contains 4 carbon atoms. So this is the structural formula. And the skeletal formula for this specific organic compound, because you have the 4 carbon atom, if you add one more methyl group, so this is the 2-methyl butane. But if you add one more methyl group, like if you add one more methyl group, as you can see that the central carbon atom, this carbon atom that contains 1, 2, 3. So this carbon atom contains the 3 methyl groups. We can say that this is actually CH3, 3 times C, and this is CH2. So CH2 and then CH3. Start numbering from either side, 1, 2. Now, the second position of carbon that contains 2 branches, 2 methyls are there. Although in the structural formula, as you can see that there are 3 CH3 groups, but the one CH3 group is in the longest chain because the first point is select the longest chain. Now, this longest chain contains 4 carbon atoms, so that's why this organic compound is 2,2-dimethyl-butane. This is 2,2-dimethyl-butane. And then if we add more than one branch, like the first branch is here and the second branch is here, so this is 2,3-dimethyl-butane. So you can also write down the structural formula. CH3 is here, CH3 is also here, so you can say CH3 2 times. Now, this carbon is attached with 3 carbon atoms, mean CH is there. Now you have another CH here, but this is CH. So CH, then CH3 is here, but this also contains another CH3. So that's why you can see this is actually the structural formula. And if you want to decode this, now look at this. This is carbon and here is a hydrogen. Now you have 2 CH3 groups here. Then there is another carbon and another hydrogen. Now 2 CH3 groups are there, but this is the longest chain. This is the longest chain. So this is butane, and the second and the third carbon, they contain 2 methyl groups. So that's why these are these two, the presence of these 2 methyls. This is 2,3-dimethyl butane. Now the different organic compounds mean the alkanes. Now, if I take the example of this compound, look at this. So if you select the longest chain, 1, 2, 3, 4, 5, 6, 7, this is heptane. And if you start numbering from either side, 1, 2, 3, 4, this is the 4th position. So this is 4-methyl And the straight chain contain 1, 2, 3, 4, 5, 6, 7. And this is 4-methyl heptane. For alkenes and halogenoalkanes, let me draw these structures. Now, if we have this alkene, then there is another alkene, then there's another alkene. Now, select the longest chain. This longest chain contains 4 carbon atom, and 3 carbon atom. So this is butene, this is butene, this is propene. Now, if we look at the position of the double bond, the double bond is present between first and second carbon. So that's why this is but1ene. And this compound is but2ene. Here you have a branch. So this is propene, but you have another branch. So that's why this compound is 2-methyl propene or 2-methyl prop1ene. If you want to draw the structural formula, so this carbon contains 2 bonds. So that's why this carbon contains 2 bonds. There must be 2 hydrogens. So this is CH2. This carbon contains 3 bonds. So it must be CH. Then this is CH2 and this is CH3. So these are the skeletal formulas, and I'm going to draw the structural formula. This position is CH3 because carbon is attached with 1 carbon. So there must be 3 hydrogens. So this is CH3. Now this carbon contains 3 bonds. So that's why this must be CH, again CH, and then CH3. Now, if we look at this carbon is attached with 2 carbon atoms. So it must be CH2. Then this carbon has already 4 covalent bonds. So there is a double covalent bond. So there's a carbon and 2 CH3 groups are there. So that's why this is the structural formula of 2-methyl propene or 2-methyl prop1ene. Now, if we have a structure like this is another structure that we have now the branch and the double bond on the same organic compound. Now here you have to use the priority order. In the priority order, double bond is preferred on this branch. So we'll have to start numbering from this side. 1, 2, 3, 4. This is not 2-methyl. This is 3-methyl. So you can say that this is 3-methyl and 4 carbon atoms are there. This is but, the bond double bond is present on first carbon. So that's why this is 3-methyl but1ene. If we want to draw the structural formula, there are 2 CH3 groups. So CH3 2 times. And this carbon is attached with 1, 2, 3. This carbon is attached with 3 carbon. So that's why this is CH. This is attached with 3 carbon. Again, this is CH. Now this is double bond and then CH2. So every carbon must be bonded with 4 other carbon atoms because carbon is a tetravalent element. Just look at another structure, which is alkene. Now, this is the skeletal formula of alkene. The first point is select the longest chain. So this is the longest chain. 1, 2, 3, 4. Or this may be the longest chain. So the longest chain contains 4 carbon atom and the double bond starts from second carbon or from second to third carbon. Double bond is present between second and third carbon. So you can say this is butene. But on the second and third position, there are alkyl groups as well. So the complete name of this compound is 2,3-dimethyl but2ene. If you want to write down the structural formula, there are 2 CH3 groups are there. So just draw the 2 CH3 groups. This carbon is already attached with the 4 carbon atoms, so no hydrogen must be there. This carbon with 4 other carbon atoms, so although there is a double covalent bond, so you can show the double covalent bond as well. between these two carbon atoms. So there is a double covalent bond between this and this carbon atom, and there are two CH3 groups also there. So this is 2,3-dimethyl butene. For halogenoalkanes, just like the double bond or the methyl group, you have to represent the position of halogen. So if we have a structure like this is CH3, then this is CH, and then there is a Cl, then CH2, CH3. Now, this carbon chain is made up of 4 carbon. This is butane, but the halogen is present on second carbon. From this side, it is on third carbon. From this side, it is on second carbon. So that's why this organic compound is 2-chlorobutane. And if you want to draw the skeletal formula, this is butane. So here you will have to increase the length, and you can represent like this. This is 2-chlorobutane. Now we can add more than one chlorine as well. If we add one chlorine here and another chlorine, so this is 2,2-dichlorobutane. If your organic compound, if it contains more than 2 halogens, then you can say trichloro. Okay, so the number of halogens, they may be increased. So these halogens, they may be primary, secondary, or tertiary. If you look at this halogenoalkane, this is CH2, then CH2, CH2, CH3. So CH3, CH2, 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 Cl. So CH2, Cl is the 1-degree halogenoalkane, means this is the primary halogenoalkane. Now, this halogenoalkane this is CH3, this is CH3, and this is CCl, but this is CH. So CHCl is 2-degree, or this is the secondary halogenoalkane. But look at this structure, 3 CH3 groups are there, and this bond is CCl. Carbon is already bonded with 4, mean carbon is already bonding 4 covalent bond. So no need to add one more hydrogen. So this is tertiary or 3-degree halogenoalkane. So CH2Cl is primary, CHCl having 2 lengths, this have the 1 length, is secondary, and CCl having 3 lengths, that is the tertiary. So this is primary halogenoalkane, this is secondary halogenoalkane, and this is tertiary halogenoalkane. Alcohol has the functional group OH, and the general formula of the alcohol, it may be like CnH2n plus 1 OH. But if you add this hydrogen to this hydrogen, you can also say that this is CnH2n plus 2O. So this is the general formula of alkane, CnH2n plus 2. If you add one more oxygen, you will get the general formula of alcohol. Now, for the naming alcohol, OL is the ending code. This is the suffix for all alcohol groups. So if you have different types of organic compounds which contains OH or OL in the name, they belong to the alcohol homologous series or alcohol family. If I say that you have a compound like this, CH3, 3 times COH. Now, this carbon is actually attached with 4 different things. Now, 3 of them are CH3. If I draw the structure, now look at this. There are 3 CH3 groups that are attached with this carbon, and this longest chain contains 3 carbon atoms, and the OH and methyl group, they are present on the second carbon. So this compound is 2-methyl propane 2-ol. The skeletal formula of this compound is this is propane. If we say 2-ol, this is propane 2-ol, and 2-methyl mean the methyl is present on second carbon. Okay, so this is the central carbon which is making four covalent bonds. Three are CH3 and one is OH. This is also 3-degree or tertiary alcohol. Then, if we have another compound, like if the carbon is like CH3, now CH2, CH2OH. Now, this is propane 1-ol. And CH2OH, like CH2Cl, this is 1 degree. 1 degree or primary alcohol. Then there is another compound. So you can say that this is the skeletal formula of propane 1-ol. If we add the OH group, like here, now this is the first carbon, this is the second carbon. So this compound is butane 2-ol. If we draw the skeletal formula, this is the skeletal formula of butane 2-ol. Now this is CHOH. This is CH2OH and this is COH. This is 2-degree or secondary alcohol. It means that if the three alkyl groups are attached, like if we have R3COH or R2CHOH or RCH2OH. So this is primary, this is secondary, and this is the tertiary alcohol. Sometimes you may have a complicated structure like this. So if you want to identify this alcohol as a primary, secondary, or tertiary alcohol, look at this area. This is CH2OH. So don't confuse with this carbon that it has three CH3 groups. This is CH2OH, so that's why this is 1 degree or primary alcohol. And if you want to draw the skeletal formula, there are three carbon atoms like 1, 2, 3. And here you have the OH, and here you have two lengths. So we can start numbering from this side 1, 2, 3. And this organic compound is 2,2-dimethyl propane 1-ol. Aldehyde and ketones both have the same general formula, CnH2nO. Mean they show the carbon to ratio like CnH2n. Hydrogen are 2 times as compared to the carbon, and if you add one more oxygen, you will get the general formula of aldehyde and ketone both. So the functional group can be represented like CHO or C double bond OH. Ketone is CO. This is not carbon monoxide. This is ketone, and it extends from both sides, and it can be represented like C double O. Here you can attach the alkyl group, like if you add R, okay, then here you can attach the alkyl group on both sides. Mean you can attach the CnH2n plus 1 on both sides. The ending code for the aldehyde is al. This, although this starts from here. So the ending code for the aldehyde is al, and for ketone is on. So every organic compound which contains CHO, that must end at al, and the ketone, it must end on. This is not one, this is on. If I say that this is your formula, CH3, CH2, CHO. So from the CHO, you can identify that this is the aldehyde. And now there are three carbon atoms. So this is propanol. If you want to draw the skeletal formula, there are three carbon atoms. Okay, one, two, three. And you can represent like this. No need to represent the hydrogen atom. So this is propanol. But if you add one more branch in it, mean if you add, like if you have a formula like this, and if you add one more methyl group, so this is always the first carbon. So one, two, three, four, there are four carbon atoms. So this is butanol, but on the second carbon, there is a methyl group is also present. So we can say this is 2-methyl butanol. Aldehyde is present on first carbon. This is always on first carbon, so no need to say that 2-methyl butane 1-al. Okay, it is 2-methyl butanol. Now, the same is the case with the ketone, that ketone can extend on either side. Ketone can extend on both of the side, but it is represented like this. This is the ketone. If I represent a formula like this, now this is CH3 group, then this is C double bond O, this is CH3. So this is CH3, COCH3. Now there are three carbon atoms, so this is prop, N, and the ending code is on, so this is propanone. If we increase the length of the carbon chain, like if we increase the length of the carbon chain like this, then we'll have to mention the position of ketone. So if you select the longest chain, this is the longest chain which contain 5 carbon atoms. So this is pentanone, but the ketone is present on second carbon. So that's why this is pentane 2. We can also add the branches in it, but the structural formula is CH3, then CH2, then CH2, and then CO, and then CH3. This is the structural formula of pentane 2-one. We can also add some branches in it. If we add some branches in it, then if this is, now this is aldehyde, this is butanol, because it is on the terminal carbon. There's a double covalent bond on the terminal carbon. So if you add one more carbon, now this is ketone. And if you add one more branch in it, this is CH3, CH2. This is making 3 bonds. So this is C, H, CH3, then C double bond O, CH3. So if you start numbering from either side, this is 1, 2, 3, 4, 5. So this is butane. So the longest chain contain 5 carbon atoms, so pentanone, but the methyl group is present on third carbon. So 3-methyl pent and 2-on. So this is the name of this ketone. But if the ketone and aldehyde, if they have the OH group, then we can use the priority order, as I have already mentioned in the third point, that if you have the structure like this, so this is butanol, but if we add OH group in it, or there is a structure like this is the structure, and if you extend it, and if you have OH group here, so this contains two functional group, but OH is not considered as a functional group according to the priority order. The aldehyde is at the top, so it will be considered as a functional group. OH will be considered as a hydroxy. So 1, 2, 3, 4, this is butanol, but the OH is present on third carbon. So that's why we can say this is 3-hydroxy butanol. And this is 1, 2, 3, 4, 5. So this is pentane on, and on is on second carbon, but 1, 2, 3, 4. Hydroxy is on 4 carbon. So this is 4-hydroxy pentane 2-on. As you can see, the structural formulas. Now this is CH3, so I can say this is CH3. This is CH. Now it contains OH as well. This is CH2. and this is CHO. So this is the structural formula. Now, to convert it into the structural formula, this point is CH3, this is CH, then it's attached with OH, again CH2, this is CO, and this is CH3. Carboxylic acid and ester, they can be represented by a general formula CnH2 and O2. This is the functional group of carboxylic acid, COOH. It can be represented like this, and this is the ester, COO or C double bond OO. So it can be extended on both sides, but carboxylic acid on one side. So the skeletal formula of the carboxylic acid, like this is, here is a double covalent bond, and here is a OH. So you can extend this carboxylic acid on one side. The ester that can be extended on either side, as you can see that this is C double bond O and here is an oxygen. So you can extend this compound on this side and on this side. So if you have the ester like this, so you can extend this on this side as well as on this side. The ending code or the suffix for the carboxylic acid is oic acid, or if you have a single bond, anoic acid, and ester is anoate. So these are the suffix for these type of organic compounds. So if you have a structure like this, so this is propanoic acid. So this is ethanoic acid. But if we extend one more carbon, this is propanoic acid, this is butanoic acid. This is CH3, then again CH2, then CH2, and then COOH. So this is butanoic acid. But if you draw a structure like this, here, if you add OH, and if you add one more branch, so this is always on the first carbon, 1, 2, 3, 4. So this is butanoic acid, but there is a methyl group on third carbon. So 3-methyl butanoic acid. Then if you add the OH group, so OH group is considered as a hydroxy. If we add OH here, so this is CH3OH, then CH2, then COOH. So this OH is hydroxy. So you can say this longest chain has a 4 carbon. The hydroxy is present on third carbon. So this compound is 3-hydroxy butanoic acid. 3-hydroxy butanoic acid. For the esters, the carbon chain can be extended on both sides. I mean, if you have this is actually aldehyde. If you add one more oxygen and extend it, this is ester. So you can represent the ester like this. In here, you can represent the oxygen. Now look at how many carbon atoms are there. Now here, this is the CH3, and this is C double bond O, and this is CH3. So I can say this ester is CH3, then COOCH3. So this part is from alcohol, and this part is from carboxylic acid. So this is methyl ethanoate because this carbon is also included in counting. So this part is methyl, this is ethanoate. So we can say this is methyl ethanoate. We can extend carbon on both sides. But let me tell you another thing, that if you have a compound like this, now this is methyl and this contains also one carbon. Now this is not aldehyde because it is C double bond O. This is methyl and this contains also one carbon atom. So this compound is methyl methanoate. Now this is C double bond O, then O, this is CH3, so this is CH3, but you have to add one hydrogen. So the formula of this compound is HCOOCH3. So you can add more carbon on either side. If you extend the carbon on both sides. Now this is the ester, and if you extend two carbon, this is ethyl. This is ethyl methanoate. But if you extend one more carbon, this is ethyl ethanoate. One more carbon. Now this part is ethyl. This contains three carbon. So this is ethyl propanoate. This is CH3, then CH2, then COO, then CH2, and then CH3. So this was the nomenclature of carboxylic acid and ester. If we look at the amine, amine is NH2. Here you can attach the alkyl radical CnH2n plus 1. Then amide is C double bond O NH2. And here you can attach the alkyl radical. See, the suffix for amine is amine, and of amide is amide. So you can use the same name. If we say that this is the structural formula of amine, so this contains two carbon atoms. So this is ethane amine. But if we add one CH3 in C double bond O NH2, so C double bond O NH2 is amide. So we can say this is ethane amide. So this contains two carbon atom, and here is a NH2. So two carbon atom, there is a double bond and NH2. So this is amide. NH2 is amine and C double bond O NH2 is amide. Then acyl chloride is C double bond O Cl, and nitrile is Cn, or you can say C triple bond N, and here you can attach the alkyl radical, here you can attach the alkyl radical. So this can be represented like C double bond O. Here you must have a Cl, and you can extend the molecule from this side. Here you have the compound like this. Here you can represent the compound like this, and you can extend on this side. Now, if I say that this is the compound CH3C double bond OCl, the ending code is oil chloride. Now, this contains two carbon atoms, so this is ethane oil chloride. This is ethanol chloride. And the ending code of nitrile is nitrile, so this contains two carbon atoms, CH3, CH2, sorry, three carbon atoms. So this is propane or propanonitrile. There are some cyclic compounds as well, in which the terminal carbons are joined together to make a cyclic compound. So this carbon, there are three carbon atoms. So this compound is cyclopropane. If you increase one more carbon, so this the structure of cyclobutane is like this. So this is cyclobutane. This one is cyclopentane because there are five carbon atoms. And this compound is cyclohexane, and this is benzene, and this is C6H6. Okay, let me tell you about all the functional group. If you have a compound like this, or you have a compound like this, or if you have a compound like this, just just identify the type of organic compound. This is butane. You can see that this is butane because there are four carbon atom and single covalent bond. So this is butane. There are five carbon atom, and you can see this is pent-2-ene because the double bond is present on second carbon. Four carbon atom, butane, but the chlorine is present on second carbon, so 2-chloroputane. This is halogenoalkane. This is aldehyde. As you can see, there are two carbon atoms, so this compound is ethanol. This is ketone because the carbon atoms are extended on both sides, so we can say this is prop and This is alcohol, 1, 2, 3, 4. 4 carbon atoms are there. So the OH group is present on second carbon, so butane to ol. 3 carbon atoms are there, but this is nitrile, so this is propanonitrile. This is carboxylic acid, but it contains 2 carbon atoms, so ethanoic acid. C double bond O, this is ester, so this is methyl, and this is ethanoate. This ester is methyl ethanoate, 2 carbon, but C double bond O Cl, this is acyl chloride, or you can say this is ethanoyl chloride. NH2 is amine. There are 2 carbon atoms, so ethane amine. There are 2 carbon atoms, so ethane amide. So this is all about the nomenclature of different organic compounds at AS level. Thank you.